Hello, hello. Hey, can you hear me, Rama?
Hi. Yeah, yes.
Okay, great. Uh, so, were you able to install something with Pavas, like virtual machine and Ubuntu or something on that?
Right. It's already there on VMware, that
Okay,
Cloudera.
okay,
So I think it has all the modules like Hadoop and Hive.
okay.
I,
And were
I,
you
I do not have much idea because I did not use it, but
okay?
I got it downloaded
Okay,
and
I'm going to.
Anaconda is there and on the Jupyter Notebook, I just installed the PySpark morning.
Oh, that's great.
Hmm.
I'll quickly take you through with my notes, and then we would
Sure.
uh, more. Let me share my screen.
Okay. Yeah.
One second.
It's fine.
Okay, I'll quickly take you through with my 101 slide, and then we would dig deeper into how to use PySpark and
Mhm.
how to use the cloud.
Okay.
So you must have seen this PowerPoint. This is from my course.
Uh-huh.
I do, I divide things into like two modules or two career tracks. One is more towards the admin side,
Mhm.
and the other is
Okay.
more toward the developer side. But that's in Hadoop.
Okay.
And the
Okay.
third side is which is only Python for big data. So there are like three tracks that I broadly defined with.
Okay.
These slides are more towards the admin. So this intro to big data and Hadoop is more on the admin side.
Hmm.
Uh, the prerequisite or the things that you need to know a little bit to start and understand stuff is MySQL. I think you already know that.
Yeah.
Ubuntu, I think you installed Cloudera and not Ubuntu, right? Or did you install Ubuntu as well?
Cloudera, I think the VMware, I think it's using Ubuntu, right? That
Uh,
Linux base.
Yes, Cloudera uses a different version of Linux. It's
Oh,
best
I think
based
I
on
did
Red
not
Hat.
use. I think I did not use the Ubuntu.
Okay, so
It's
let me
there
show
on VMware. Yeah.
you. I'm going to show you that. And MySQL, Ubuntu, Java, and Hadoop all are open source,
Yeah.
although a lot of modules of Cloudera are not open source because it's a for-profit company.
Okay. Okay. Hmm.
So a lot of banks, I have worked with Goldman Sachs and Bank of America, they prefer. Hey Nehal, thank you for coming. We just got started and I'm on slide one. So you are on time. Nehal, you did not miss anything. I'm just starting everything from between. So if Rama need any help, then you would have to take care of that. Okay. So when the Cloudera is a paid tool, a lot of modules that they build, they did not share us the source code. So therefore, banks don't use Cloudera sometimes. They would rather ask like the TCS and the Wipros and all the consulting companies to build tools for themselves or use something for which they can see the source code.
Hmm.
So that's their one preference. Like when I was working with Goldman Sachs, they used IBM and they asked IBM to create whatever Cloudera was doing. So IBM had their own stuff and they shared it. But the idea is everything is open source and open source technologies are going to jump.
Okay.
Now, when you installed VirtualBox, we have two things. One is VM Virtualware, which is Oracle.
Hmm.
Sorry, VMware and Oracle VirtualBox. I think you used
VMware.
VMware. Yes, VMware. Now again, VMware has a paid option as well, which gives you better features.
Hmm.
But Oracle VirtualBox is completely open source and free. They don't have anything that they are selling.
Okay.
So a lot of time people prefer VirtualBox because it's completely open source and whatever they are doing, they are putting it there for the cloud.
Okay.
But VMware is a little bit faster and easier to use. terms of its stability.
Okay.
Okay, let me move to. So, what is the difference between Hadoop and Cloudera? Or what is the difference between Big Data Hadoop and Cloudera? Or what is the difference between HDFS, Hadoop, Cloudera, Big Data? So Hadoop is the whole operating system. Cloudera is a company that brings together all the tools which are independently developed for big data world, like Hive, HBase, like Kafka, any messaging technology or any structured like SQL kind of a thing for big data, which is Hive, or an equivalent of Cassandra and MongoDB in the big data world, which is HBase. So Cloudera brings all these projects, install them on an open source, and sell them. And with putting their own tools on how these things are getting connected and talking to each other.
Okay.
So Cloudera is like getting all the open source things here and there and making a system so that we can use them. So, but 90% or 99% of the thing that is on the VMware Cloudera are open source, except Cloudera has only a few tools. I'm going to show you the front end that is proprietary Cloudera, the thing that shows you the status of everything and things like that. Okay, if we were to dig deeper into the development side, then we have to learn a few Linux commands. So there are two ways in which I do it. For the very quick world, we would see Cloudera and look at all the different technologies that are available in the big data world. The other is we install everything from scratch. So I used to have a 6-month course before COVID where we used to do all the technologies in SaaS from scratch. I launched it with a company called Kaisertech, but they had to stop it. So I developed with these guys, Kaisertech Inc. They're based in Queens. So we had a full-blown course with all the modules for like 6 months. But that was installing everything from scratch and connecting everything, which otherwise Cloudera has already done. But the problem is, if something goes bad in Cloudera, we don't know how like Hive is connected to Hadoop and how all these things stuff, Kafka and all these things. So we are going to look at all the things so that at least we know the names for now. But otherwise, if we dig deeper on the admin side, then we should know how to install it, how to look at the error, how to optimize them, and so on and so forth. In that case, we have to learn a little bit of Ubuntu command and a little bit of the infrastructure of Hadoop, like the security, the environment variables, and all those stuff. Now, there is one thing which was one of the technology that was highest paid in continuously 2 or 3 years. It's called MapReduce. Did you get a chance, or have you heard about MapReduce? Oh, Rama, can you hear me? Nehal, can you hear me? Maybe you forgot to unmute your mic, Rama.
Yes, sir, I can hear you.
Rama, I cannot hear you.
Yeah, hi. Yeah, I'm listening. Yeah.
Yeah, okay. Did you get a chance to check out MapReduce? And what did you understand by MapReduce? That's very
No.
Okay,
I'm completely new.
Okay, but I'll show you why this is important, because
Sure.
if we understand the money, then it's easy to understand what is
Okay.
happening. So if you Google highest paid IT skill 2019, and if I go to like DICE or any other website, they talk about different tools, and there is a whole paradigm called MapReduce. If you see here, the 8th one, it used to be number 1, but the funny part is even Kafka uses MapReduce on the back. If I go to this quickly, this DynamoDB, this is a NoSQL database on Hadoop.
Okay.
So if we know Hadoop and if we know any NoSQL database, then we can link and understand the whole story. So DynamoDB is a distributed database developed by Amazon to run on Hadoop. Now, Amazon does not call Hadoop as Hadoop. They call it as Elastic MapReduce. So when they use the same thing, they use different terms. So we should not be worried about that. This Redshift This was very similar to Tableau. If you have heard about Tableau. Tableau is for making quick graphs and charts for like MIS reporting, Management Information System reporting. Cassandra was another NoSQL database. DynamoDB is also a NoSQL database, but Cassandra is not on the big data world. Elasticsearch is the Hadoop name for Amazon. It's their own stuff, but this MapReduce is what I want to talk about. So till the time we were working with supercomputers or just one computer, all of our data used to be stored in one hard disk. But MapReduce allows us to do distributed calculation. If you think about it, there are two steps to big data. One is storing big data, and the other thing would be using big data. So the storing big data goes with the infrastructure of Hadoop distributed file system. And working on big data, that uses the paradigm of MapReduce. And we'll see how to use MapReduce examples in PySpark if we get time. Otherwise, I have it in my videos. Okay. So the first part is Hadoop big data stuff and understanding the whole architecture. Let me start with the simple most example of how and why we are using Hadoop. So we have our data which gets distributed in a lot of places. A very classical example where the story began was with the banks. Bank had a lot of transaction information about transaction, and there were so many transactions happening with the bank that they were not able to store all the information in one computer. So they devised and stored all the information on a distributed grid. If you look at the architecture, we have something called the name node on the top, and we have something called the data node on the down right. The data node has the data, which are also called the worker nodes, and the name node is the node that has information about the data. So there is nothing stored on name node. These 1, 2, 3, 4, 5, 6, 7. These are the blocks of information, and they are stored on different nodes. And one node is one computer. This one node is generally one computer that we buy on Amazon, and the cheapest computer that we use for a very small setup would be like $20 a month or $30 a month. So these are individual computers, and all of these computers have Ubuntu installed on them. And that Ubuntu, and name node also has Ubuntu and Hadoop installed on it. So the native operating system on all of these computers is Ubuntu. On Ubuntu or any Linux, we are installing Hadoop, and that Hadoop level is talking to have this whole paradigm set up there. Why did we need this? We need this because the data became so big that we cannot save it on one computer. We have to use different computers. Okay, if you have any question, you can stop me, Rama. Just let me know. I'm going to do pick up some speed. Just stop me if you have any question. So I told you there are two layers in the big data world. One is, yeah, you have any question?
No questions. Just.
So if somebody asks us, what is MapReduce? Do you know anything about MapReduce, or do you know anything about Hadoop? So the smallest project that we do is on DigitalOcean. If you have heard about them, they are more transparent with their pricing. Amazon, that has happened 2 times with me. If you forget to shut down something on Amazon, they charge you bill and they bother you. While DigitalOcean, it's like Amazon or Google Cloud. They have like flat rates. Like you use a computer and they're not going to charge you more than $10 per month. And they don't have things where if you use high, they charge you high. And Amazon is not as transparent and easy to deal with. So 2 times Amazon closed my account because they gave me bills for something that eventually I never knew that I was using. And even there are like hundreds of services. So the practical implementation, if we were to do, we would do this on DigitalOcean. The very simple websites, if you are building a website or a small business thing and the size of the data is like 30, 40 or 50 terabytes, or like even less, 20 or 30 terabytes. And if you use a normal computer, then still you cannot handle like 30 terabytes of data. And 30 terabytes are not that big. The computer that I'm using to take this class has 1 terabyte of hard disk. So 30 terabyte is not that big of a data for a lot of stuff when it comes to, especially when it comes to like something included image and video, which we use for machine learning and all those stuff. So we have two layers, the Hadoop file system layer and the MapReduce layer. This is the storage layer and this is the calculation layer. Both have the same computers doing the stuff. So the data is distributed and saved into different computers. Likewise, the task is distributed and operated on different computers. So when we are storing the data, we are using the same computers that we are going to use to solve any computation that we need. So MapReduce becomes critical because we have to write code that works in a parallel way. I'll give you an example, very simple example. And if I have 100 numbers and I want to calculate average of those 100 numbers, and it's stored on just one page of your notebook. To calculate it, you would just read those numbers visually on the same page of your notebook and give me the sum, right? But if the same information is stored on 10 different pages, what would be your algorithm? Your algorithm now you have to write it in a completely different way. As a human, the algorithm would be take the sum of the first page, write it down below on the first page, go to the second page, take the sum, write the sum down on one page, do it for 10 pages. After that is done, go to each page and wherever you wrote this sum at the end of that page, copy that thing and give me the final sum, right? That's how we would do it if we want to take sum of numbers that are written on different pages in the notebook. That thing is called distributed computation, or that thing is called MapReduce. And mapping and reducing are two steps. So the part where we take the sum and write the sum down on each page of whatever numbers are there on that page is called mapping. And the part where we go to each page and just take the final sum and add those 10 sums, that is called reducing. We'll look at more examples of this as well. But to do this, we have to think about new ways to do the same math, like the big data libraries. If you observe, they use, if you have heard about things like regression, logistic regression, or classification, and all the fancy algorithm that we use, whether it's for image processing or voice recognition or anything, these were made to work in a non-distributed fashion, which means that they were made in a way where we assume that all the data is on one computer or one file when we read it. But what if the data is stored on multiple files? Then they had to rewrite all the algorithms. The other part is the computation power is also distributed on these computers. So we cannot do the computation at one central computer. So I cannot tell you that tear apart all the 10 pages from your notebook, put them on a big table, and then take a big page and do the sum on the big page. We are not allowed to do that because we don't have a big supercomputer that's going to do our calculation. So not just we have a limitation where we are distributing and saving the data, we have to also compute them in a way in which we keep all these computers which we buy. Okay, let me know if you have question to stop me there. So the stack looks like this. Below is the Hadoop file system. On top of that is the Hadoop operating system. It's also called Yarn. On top of that is our processing algorithm. Okay, we are more interested in knowing about the technologies for now, so that we can know what kind of things exist, because 99% of the time in interviews, they don't go a lot of technical, because even from last 3 years, I do a lot of things which I don't know, but I know the broad idea, but I don't know what is the exact command or how to do it. So it's very important to understand the broad idea and different technologies that exist. So on your screen, you see the Hadoop file system, Hadoop distributed file system. If you want to find out the cluster configuration, if somebody asks you, have you worked in Hadoop? How was your cluster? Then you tell me a little bit more about your cluster configuration. And if this is the diagram, then if you see this is one computer, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. So this is a cluster of 30 computers. And what is the normal configuration of one computer? Generally speaking, is like 1 or 2 terabytes of data. So this whole cluster is like 60 terabytes of data. Now, if we are making, if a company is using some place where it's storing big image file or video file or some file that is like 1 or 2 terabytes every day, or like 3 terabytes every day, then we are going to store them in the Hadoop file system, and we are going to delete them after some time. Or when we go into deeper, we see how to take backup and put it at some other place. But this configuration of this cluster is 30 computers. Each computer is like 1 or a 2 terabyte computer. And it has the same kind of CPU, which we have like 8 cores and whatever it is. Remember always that Hadoop does not use supercomputer. They use something called commodity computers, which is the same computer that you and I are using. So the Hadoop cluster is built up of the same cheap computers that we are using, which most of the time a computer costs like $800 or $1,000. So this is the configuration of the Hadoop file system. If you are doing any starter project when you join a company or when you're working, you can always easily back up or practice with a small cluster of like 30 to 50 nodes, storing about like 50 to 100 terabytes of data, although it becomes bigger in other cases. Now, why would this also become important? Because if you had a file on your computer, if you're using Python, and you have a file which is like 2 GB or 3 GB, if you observe, you cannot store a file that is greater than, I think, 32 GB or 16 GB on your RAM, because otherwise your RAM will get full, right? If I give you a file which is 500 GB and I ask you to load it in a pandas data frame, if you have used pandas or any variable, we cannot take that 500 GB file and store it into a variable in our normal world. The only way in which we can do it using is the big data world, for which the language on the back end is called Scala, but we also use PySpark to do the same. So using PySpark, if a file is distributed here in all these computers, which means that 10% of the file is on the first computer, another 10% is here, another 10% is here, we can still load them. We cannot put them in one place, but we can create a pointer, which is something called lazy calculation, because we are going to accumulate them at the final word. But we can create a variable and assign that 500 GB file to that variable. If we try, first of all, 500 GB cannot be stored on your computer that easily. Even if you do, you cannot load it into a pandas data frame. So that is like a limitation. For example, I'll give you an option. If you want to, if we are installing some image recognition in a self-driving car, we need to get all the data of all the images from the day, keep it with us, and whenever there is an accident or something happened where the driver had to interfere or do something, we have to keep on training that data or keep on making changes. In that case, the data is so big that if you were to run any image recognition on that data, which will include what was happening when some accident happened or when any feedback loop from the driver, we cannot store those variables in just one variable. So all of these things would become critical when we are going to use big data. Likewise, SQL has its own limitation. If you create a table in SQL, the normal SQL that you have, if I assume you must have used like Oracle SQL or Microsoft SQL, you have again a limitation in SQL that it does not support the grid infrastructure that well. So if you have a table that is like very big, then they use something called indexing and they split it apart and do all kind of crazy stuff, but that's not efficient and fast. So this Hive does whatever SQL can do, but it is at the end, it's all a map reduce. So even we can go deeper, and if you remember something like group by in SQL or joins by SQL, those are written in the map reduce way in Hive. Likewise, the same thing happens in NoSQL database here. Likewise, we have an in-memory database, and this in-memory database is very critical. In the bank, if you move your money from your saving account to checking account, in India, we do it using mostly NEFT, so it takes a long time. But here, if you see, we have a checking and we have a saving, and when we move money from one account to the other, it goes in instantaneously, right at that moment. So all those calculations or all information about just the money of your account is stored by a bank in an in-memory database so that they can change it. But all other information like the name of the account holder or something that the bank does not have the infrastructure to put in memory, it's going to put on the bank. So if you want to change your address, if you go to your Bank of America account or Wells Fargo account and you change your address, you will see that it's going to say it's going to take a couple of hours or one day. A lot of time this is because of regulation. A lot of time is because it is stored in the Hadoop file system and not in the in-memory database. So to propagate it in the Hadoop file system, it's going to take 1 or 2 hours because it has to find where your information is saved, where it is replicated, and all those kind of stuff. So for doing anything very quick, we used in-memory database, which again we can use PySpark to do that. Now, how does Python become important? Why did I ask you to install a Jupyter Notebook, or why are we going to use Python? We use Python because we can run Spark in Python. We can also use Python to connect to the Hive servers and get data from Hive and store it into a PySpark data frame, which is a distributed object. Because as I told you, whatever we capture from anything here on this page is going to be a big data object. So if you spit off a SQL table and we want to capture it into a SQL table, we want to do some calculation, like calculation that we would otherwise do with pandas, like group by or joins, or even some more programmatic calculation, then we have to take the Hive object and save it into a PySpark data frame. So that's where it becomes very important. That's why all of the job these days requires you to know big data and PySpark, because 99% of the time they are handling data that's big enough, which is not going to go into pandas database or traditional programming languages or not SQL. Did you and Fawaz was and Fawaz, thank you for coming. I'm on the 6th slide of my Hadoop 101. I think I already shared you this file many times. And we are talking about all the technologies that are mounted on top of Hadoop. Rama, did you encounter anything, or did you see any of these keywords somewhere when you were checking out big data courses or job or anything?
Oh, I didn't check that one completely.
Okay, but anything on the screen that you have heard? You must have heard with SQL, right?
Yeah.
Okay.
Right.
If you see in SQL, if you write a crazy query, it gives you a timeout, especially if you do something like cross product or something.
Mm-hmm. Okay.
So, and in SQL, which SQL have you used?
So I think it is there in this. Earlier I used the Snowflake, but
Okay.
MySQL, I have a little bit idea about the MySQL. Yeah.
Okay, so all these MySQL and stuff, they cannot store large amount of data, and if the table becomes too big, they don't have the capability to handle it.
Okay.
And a lot of time, Microsoft SQL Server just hangs up if you try to do any crazy calculation.
Okay.
Okay, so the interim space, the way in which we are going to store the data is going to be called Hadoop file system. Most of the companies right now, a lot of job that you should understand is like moving file from your computer to the Hadoop file system. And there are some commands to do that, because just imagine if you're working in a company and you want to work on a file which is like 2 GB or like 200 GB. So of course your computer is 1 terabyte, so you can have that 200 GB file that you downloaded from somewhere or which you saw from some place. But when you have to move it to the Hadoop file system, then you should know the Hadoop file system commands. So there are few commands on Hadoop file system, but let's understand the architecture and the need for the architecture and how it helps us. So if we have a 120 MB file and we want to use it, the only thing that stops us from using any of the computation is the hard disk. Because if you observe and if you think about it, CPU works very fast. It can work or process like thousands of megabytes per second, and the same with RAM. But the rotating magnet hard disk, that's the slowest thing. And most of the Hadoop computers right now, at least till like a year or two ago, was still using rotating magnetic hard disk with a speed of only 10 MB per second. So the read and write speed is the real troublemaker. Beyond that, we can work with data very quickly. Let's see how Hadoop helps us in this regard. So if you want to store 120 MB file, and if you observe at this architecture, I'm saying that I have 4 hard disks or 4 nodes. And what I'm going to do is I'm going to replicate the data. So hard disk 1 and hard disk 2 will have replication of data, and I'll break the data into 2 parts. So I'm going to take this 120 MB, store half of it, the first 60 MB on hard disk 1, the next 60 MB in hard disk 2. Again, I'm going to keep a copy of the first 60 MB in hard disk 1, and again, I'm going to keep a copy of the second 60 MB on hard disk 2. If we do this, if everything is working in parallel, you would get double the speed, just because by the time you are taking this 120 MB file and storing it into this 60 MB, you can in parallel store the next half into this 60 MB. And in parallel, you can just replicate them and keep storing everything for the clones. So by doing this, assuming that this computer is very fast and this computer is slow, this is your master computer, which has 120 MB file. So this computer has a faster hard disk read and write space. But whenever, if you were just using one computer and you wanted to transfer this into your commodity computer, and that commodity computer reads at a speed or writes at a speed of 100 MB, then you would have taken 12 seconds. But if you use the Hadoop setup with your commodity computers, and assuming that your main computer is very fast, you can get 2 times speed up if you divide everything into 2 parts. So we have 2 things. One is called the distribution factor, and other is called the replication factor. So they always ask that when you are setting a cluster, what was your distribution factor and your replication factor? So replication factor is mostly free on all the places that we use, because uh, replication factor 3 means that you are going to have 3 copies of each of the file that gets distributed, and it's very hard to see like 3 out of 3 going bad. You have to like destroy a lot of grid, or a lot of data corruption is needed. And the distribution factor here is 2. So we are dividing everything into 2 parts, and the speed up is achieved by distribution factor. If we divide everything into like 10 parts, then we can store 12 MB on 10 computers, and we can do it in just one second. So we get a speed up by dividing data into small part and in parallel sending them to the commodity computer. Now, one interesting thing here is that I never talked about the transmission speed from the main computer to the slave computer. So again, transmission speed is unlimited because it uses optical communication. So the speed at which we can transfer data is faster than the speed at which we can read or write data on the rotating magnet hard disk. So the only thing and the biggest blockade that we had for a long time, still we have, is the reading and writing of data. We can do computation very quickly, we can do transmission very quickly, but we cannot store data very quickly. And that's where Hadoop became important. This is again a quick revision of Hadoop file system, HDFS, which says that there are data nodes, and these rack are like geographically located computer at the same place. The idea was that if suppose one of them is located in India, one is located in US, and one is located in Europe, and something bad happens with the wires in the sea, then we don't lose all the data from that company. Because if you know, all the wires come from the, I think, the Pacific Ocean, if I remember it right. And if something bad happens through that wire, the internet can be shut down or can be slowed down. We don't feel it as a retail user because we don't use that high of a speed. But if we are using a big bandwidth, and if something bad happens in the sea, we want to make sure that we replicate along the rack. So one copy of the data is stored in US, one in like Europe, and one in Australia, and so on and so forth. Again, the same diagram I'm keeping repeating. So the name node is the master node, which has information of where the data is stored, and otherwise we have the data stored. Many years ago, when Yahoo was at their prime, this is the kind of cluster that they were using. for their entire infrastructure. So the whole yahoo.com, if you want to find out how many computers are actually working to have that search engine ready, 10 years ago, their cluster had like 3,500 nodes. And each node was like one computer of 2 cores, Red Hat Linux, 16 GB RAM, and 4 SATA drives, 1 terabyte each. If you go even cheaper right now, most of the time companies are using the rotating magnetic hard drives. And there is another concept called RAID, R-A-I-D. I don't know if you have heard about that, but RAID allows you to have parallelism and distribution on one computer by installing 4 hard drives. So that is another level of backup that we had. Okay, this is what we are going to look at right now when we are going to start the Cloudera. Now, some of these technologies are built by the open source, and some of them are built by Cloudera itself. So here, whatever is on the screen is mostly built by the open source one. We have Hadoop file system down, then we have the Yarn MapReduce framework, which is for distributed computing. On top of that, we have different things that we are using, like we might use machine learning. This PIC scripting is to write script to do some simple calculation on this data. And those simple calculations would be like, for example, if you have name and surname and only these two information, or a simple file which has got name and surname distributed across, and you want to like find out the number of times the surname is located, or when the surname is something, then you want to find out which city is a, or something like that. Whenever you want to do something very easy and specific, then you can write your own MapReduce here. But in the PIC, you have to write your own MapReduce. This OZ is a workflow. It keeps a track on how the data is this OZ is keeping a record of all the tools and what's happening with them. And this Zookeeper is the coordination system. I never use these one because these are like hardcore the admin side. The more often the thing that we use in the Cloudera tutorial is Sqoop and Hive and PySpark. So those are the main ones, because although most of the data today, 98% is unstructured, but still we are mostly using SQL and working with structured data, and the other type is NoSQL data, which is stored as like JSON format or in Cassandra and MongoDB, which is again Edge-based. Hadoop uses commodity hardware, which means that the computers are not that crazy. This was again from one of the examples in Yahoo and other servers, that the new data created was like 12 terabytes. The data that was scanned was like 130 terabytes. And of course, you cannot have this thing unless you're using a distributed computer. Now, if you were to design the whole Hadoop grid, and if you had a data in which you are using 135 data every day, and you are generating 12 terabyte of data every day and using and scanning 135 terabyte, and the total data would be like at least 1,000 or 2,000, which means that if each computer has 2 terabytes, you need like a grid of 500 or 600 computers, assuming that you use a replication factor of 2. The same idea, but with a different figure so that we get the idea. So HDFS is file system or storage, Yarn or MapReduce, you can call it either, which is how we talk to this data. And on top of that, we have different things running. This is Cloudera, and this huge thing is developed by Cloudera. That's why they're adding the value. Other than that, everything on this screen is open source. I think they developed something parallel to Hive, which we are going to show as well. They developed their own distributed SQL. But most of the time, we are going to deal with this framework. And the UI UX framework, when we start the computer, is going to be here. Okay, a very simple MapReduce program used to look something like this. If you have okay, if you have a data where it says hello world and bye world and hello Hadoop and goodbye Hadoop, that's your final data. And you want to count and give at the end, how many times did you use each word? And if you want to do this, then how would we do it using MapReduce? And this shows the example. I think I will quickly talk about it. So this hello world and bye world is stored in one node or one computer, and this is stored in another computer. Now the idea is when this is stored in one computer, you have to do all the calculation on that computer, which is like first to create this mapping 1111. Then in the same computer, you can do and count how many times hello is coming on this computer. Once you are done with everything on that computer, then the two computers can talk and synchronize the data and find out how many times this was used. The idea is to understand this thing, which is if you want to do anything, mapping or anything could be done on one computer. All these things would be done on separate computer as far as any mapping or any calculation is done, and then you would shuffle. If I were to use the example that I gave you, I should put it here. If you have got a copy and you have got these 10 pages and you have got number here, and I ask you to take the sum of all these numbers. So you're going to go to each page and write the sum here below. And once you do that, you're going to sum these things up. The idea is the same. These things are stored on different computer. This page you can assume as different computer, the page of the copy, and whatever calculation you do on the page is done by that computer parallel. So the same idea goes for MapReduce. Splitting, mapping, these could be done parallelly on computer. The only thing that happens, which is the slowest stuff, is shuffling, where you have to get data from two computers and add them up. So we have to write a code. They already coded all of this thing when they decide the map, when they designed the MapReduce, that we should use minimum shuffling. So the shuffle is the most expensive step because in that step, two nodes have to talk with each other, find out, hey, what did you do? What did we do? And then what? We have to always remember that we cannot bring the entire data on one computer because there is no master computer here. This node that we is taking care of everything. This name node is not a supercomputer. It's a fast computer, but not a supercomputer, which means that you cannot take all the data and dump it on the name node. The only thing that you can dump it after this calculation is a very small data. So you cannot just like dump a big file, 50 terabytes somewhere here, because this name node is like a normal computer, 2 terabyte or 3 terabytes. So you need to make sure that after your calculation, whatever happens is in a format which is short enough. So that step is done in the shuffle step, where you will talk to each computer and say that, okay, whenever we are combining or fetching and merging, it should be a very small data, so that after I do the reduce step, I should get one. In our case, where we were doing paint, we can write, what we are going to do is when we calculate the sum on each page, we are going to take this sum, add it here, and take this number, add it here, take this number, add it here, take this number and add it here. We will not say that, okay, let's bring all of these one, even though it's one number. So let's not bring all of these 10 numbers on one computer and then add it. So that's the idea, that we have to write the algorithm such a way that the fetch and merge does not bring all of the data in one computer. Although this is done on the back end, and when we write PySpark code, we won't even realize that something like that is happening. Okay, let's move to the next level. Rama, do you have any questions?
No questions.
Okay, let's quickly do, so that if somebody asks you, I want to make sure that
Sure.
you can. Okay, just I'm going to ask you some question. Give me an explanation, and I'm going to fine tune your explanation. Right?
Okay.
Okay, if somebody asks you, why do we use Hadoop? So how would you reply that thing?
Oh.
You can try, I'll help you with the answer. So you will say that traditionally the data was not that big enough. Traditionally, we were able to store data in SQL database and in one computer. Traditionally, even big companies like Pepsi and Coke were storing all of their data in like one computer, like if you go 10 years ago or 20 years ago. And traditionally, these companies were not using anything like machine learning or like data mining or like saving all the crazy data and finding out all the analytics. So the data becomes so big that we had to come out with something where we could use distributed computing and distribute data into different nodes on different computers, and also distribute the calculation in different computers. So that's how the use evolved, right?
Yeah.
Okay. The other question is, have you heard about MapReduce? What is MapReduce? Because as I told you, it's one of the very important
Right.
skill.
So I
So
think
MapReduce is the computation layer where we do things in two steps, mapping and reducing. It was required because we cannot dump the data on a supercomputer or a fast computer. So each node has to map, and then we have to reduce whatever is processed on one node. So the reduce step is collecting or reducing all the thing that was done in the mapping step at each node. And why do we need map reducing? Because even for calculating simple things like sum, average, standard deviation, the old algorithms that we had in Python or C++, they were not working because we were not able to store data into the memory. Because if you remember, if you go deeper into how things work, we were able to, the C++ compiler and all those classical world would be, we would store things in our RAM and then say that, okay, one number is located in this address, another number is located in this address. Go and take the sum and store it on the third address, and so on and so forth. Here we cannot even use the RAM, or we cannot store that thing into a variable, that big data. So we have to use distributed objects, and we had to do distributed computing, and that's where MapReduce became important, where we had to redefine in a way on how to do the same calculation in a distributed manner. A simple example was like when you want to take sum, if everything, all the numbers are written in one page versus the numbers are written in like 10, 20 page. So if earlier all the numbers were in one page, so we could take the sum and do it on the other page. Otherwise, we have to like do the mapping step where we sum all the numbers on individual pages and then we reduce it, which means that we take the sum that we do for each page and then add them all up, find the sum of all numbers. Okay, will you be able to talk a little bit about MapReduce? If somebody asks you, what do you understand by MapReduce, why it is needed?
Yeah, I got the concept. So I think when we are taking the use data, we have to put it in an order based on the similarities in the data.
And we have to
mapping
distribute
and
it into different computers because we cannot store it into one computer.
Right.
And
And
then how will we do the calculation? We have to write distributed algorithms, or we have to write how to handle that data.
Okay. Yeah.
Right? Like the algorithm I told you, which was like take the sum on each page and then write it down on each page and then go through each page and keep adding these sums.
Okay.
Right. So MapReduce is a way to do computation in a distributed manner on a distributed cluster.
Okay. Yeah,
okay. What are the two types of or three types of data that we have? One is structured, which is SQL. That's why SQL is called structured query language. The other data is mostly JSON or dictionary data, which is all the JavaScript and the APIs, all kind of communication happens at a JSON level or like key value pair. So the second type of data is JSON or key value pair, JavaScript object notation or key value pair. And the third type of data is completely unstructured, like music file, image file. So when we want to save these kind of data, then we have to use different technologies. So if somebody asks you, have you worked with DynamoDB? So you should just know that DynamoDB, and you can read more about it, is because each company is launching their own product. So even if the idea is same, it's the same thing. So DynamoDB is a NoSQL database where you can store JSON kind of data or key value pair kind of data in a big data infrastructure.
What is the second one you're saying? Key value.
a key value.
Oh, okay.
So it's a NoSQL database.
Okay, okay.
You have to always remember the difference between NoSQL and SQL database. In NoSQL database, you have tables and you know what data you're going to get. In key value pair, you don't know. You just save it into key value format.
Oh, okay, got it. Okay.
So earlier we were using something like MongoDB or Cassandra or these tools to store it. But now when we are in the big data world, we have to use the other stuff.
Mhm.
Okay, 1 second. Okay, the other question would be, oh, yeah, which page was I? Okay, so key value is done. This is done. What would be the other question that would be asked? So you should let's talk about a little bit of why we need Hadoop. What is MapReduce? The other question is, have you used something like Hive, or why is PySpark so important? Have you worked with PySpark? So can you tell me something about PySpark and why do we use it? I'm going to give you one hint. I'm going to take you to the page where you have some content to talk about why we use PySpark. So PySpark is the Python implementation of Spark, which helps us to get all these distributed objects into Spark data frames. So when you have a Hive table, or you have an Edge-based table, or you have a NoSQL data, you can store everything into a Spark object and work them like you were working any Python object, like pandas or NumPy arrays or anything. So even if you want to create an array, like just like simple array, one-dimensional array, you can do it into Python, NumPy arrays or list. But in the big data world, that thing is distributed. So you cannot just bring that thing and put it into your memory. So if you want to create a distributed object, because this Hive table is a distributed object, the Edge-based table is a distributed object. Even if you store image or dump anything on Hadoop file system, like an image or a movie, that's a distributed object. So PySpark can help us work with distributed object and do any calculation, computation, machine learning on that, any algorithm we can run on that using Python, a very simple language. So that's why we use PySpark. And we'll see a quick example if time permits us. Okay, Yarn is the same as operating system. So just remember that. This Impala is something that was developed by these Cloudera guys. Okay, now I'm going to stop my sharing. Let's see if we can start the Cloudera on your computer.
Okay.
And let's see if we can use that, because then you would be able to do a lot of stuff. Let me see if I can stop. If it kicks me out during stop share, I'm going to join the meeting again. There was a bug that they had to go.
Okay.
So let me try to stop share. Oh, it did not kick me out. I'm making you the host.
Mm-hmm.
Yes, you are the host. Now, can you start your share your screen and start Cloudera so that we can see all these things in action?
Okay. Yeah. See this?
Yes. Oh wow, you already started it. That's very nice.
Yeah. I don't know much, but
okay,
I can't do. If you want to do it, you want to take the what it is
yeah,
called,
I'm going to
access.
take the control.
Yeah.
Yes. So I'm requesting the phone control. Okay, I think I have the control. Yes. So let's see. Okay, maybe it's slow or something. We'll figure out. Can you click for me on Hue, H-U-E on the screen? On the top left, Hue. Yes. Yeah, I think there is a screen sharing is not able to get me inside the virtual world or something.
Oh, okay. Mm-hmm.
Okay, so first of all, this Cloudera is extremely resource hungry, and I'm going to tell you why it is. I think the username and password is Cloudera. Fawaz, did you remember the username?
Never use this one.
Okay.
What is the spelling? Cloudera.
Cloudera. Yeah, this thing is resource hungry because it's starting all the services immediately.
Mhm.
If we just install Hadoop, then it's going to just start services that we want. I'll show you. Now, when we start this Cloudera Hadoop, it is starting Hive, it is starting Edgebase, it is starting all the things that even we don't need. It is starting Kafka server. It's starting so many servers that it's destroying our computer. But the thing is, there is an order to things how they would start. Like for example, first we have to start the Hadoop file system, which is similar to like placing a hard disk on your computer. Then we have to load the operating system, which is starting the yarn, which is the operating system. In our case, it is Windows 7 or whichever it is. And the third would be something on top of it, which would be high.
Mhm.
Okay, so Q is, and can you go on the top left on the three button? Let's see. No, let's go to Cloudera Manager. Can you open another tab and click on Cloudera Manager?
Okay.
So I want to see a place where it's going to show us the status of all the services that it has installed for us. A lot of these projects are developed independently, which are not even done by the same guys, the Apache guys. These are developed by different systems, different people, different groups. So these Cloudera guys are trying to make everything on one place and then selling it.
Hmm.
It's like collecting everything that is free but asking money to sell it. But the thing, a lot of time companies buy it because they don't have the time and the resources to like deploy everything and like bring everything into one place and like check. And the other thing that Cloudera does is that the version compatibility, they check it so that uh, everything is working. Let's see, attempting to connect. Okay, I think to connect it, you have to run some code on the console. So let's minimize this screen.
Okay. Oh no.
And click on Launch Cloudera Express.
This one.
Yes, Launch Cloud. Yes, let's click on that. Yes. Press Enter. Oh, no, sorry. Can you copy that command? Sudo home Cloudera force. Yes. 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 Now you can open a new terminal by using top right. There is a terminal window. Oh no, application, places, system, and then the last terminal. Yes. Let's open that. Let's paste it. You have to right click and paste maybe.
Oh, okay. Box.
Or you have to go again and copy it. So, oh yeah, Control C is not going to work. So you have to right click and copy. Okay, you can write Express after that. So use the up button.
Mhm.
Use the up button to, yes, click here and use the up button, the button up and down button on the keyboard.
Oh, okay. Okay.
And then write space dash dash Express. So after force, you have to specify Express. Yes. EXPRESS. Spelling is there. Yes.
Enter.
Enter. Okay, now it's going to start everything. It's going to start the Hadoop file system, then it's going to start the Yarn operating system, then it's going to start the, you see it says that Kafka server is not, they did not configure it or something. It's going to start Hive, it's going to start Edgebase, it's going to start all the services. And that's why they say that you need 8 GB RAM and very powerful computer to run this. Now we cannot have it start just one thing, because whenever we want to work with, suppose, even when we are working with PySpark, the
Mhm.
data is still stored in Hive, because that's where we are storing the distributed SQL kind of data. So if traditionally we are storing SQL data, like the banks would store structured data, which would be like the name of the person, the address, and all those stuff. They don't want to go into unstructured world to save structured data because the data itself is structured.
Okay.
So the structured data would be stored in Hive. So when we want to work with PySpark, we have to start the Hadoop file system. Otherwise, we cannot read any file. Then we have to start the Yarn operating system, which is like the operating system which runs on top for the Hadoop. Then we have to start the Hive services so that we can read or write any table. And then we have to start Spark. So all of these things are going to be starting one by one. I am afraid that this might be, how much RAM did you use for this computer?
I think it's 16 GB.
Okay, and did you give 8 GB to this computer?
4 GB, I think so.
Or 4 GB? Okay, you might have to do that again. But if that does not work, oh, it started.
Oh,
Okay.
it started, yeah.
Yeah. Now, since they gave us this whole package, the other way is we install our own Ubuntu and install Hadoop on our own, which we could do otherwise.
Okay, so Kafka server is not recognized, right? I hear it is somewhere here. It is.
Oh yeah, that's not a problem. Kafka is a messaging service. So if you remember, when we want to send messages, before many years ago, you could not send image. You had to use like only text, like some of the messenger, like Yahoo Messenger, this and that. So when we want to use big data to send messages, then we use Kafka.
Oh, okay.
So because there are two things to this. One is like saving big data, but if you just want to send messages for the big data. So it was invented by LinkedIn.
Okay.
And it is used for messaging, and it is very popular. So all the instant messaging that has text, videos, everything, that is using Kafka. Kafka job became the highest paid because all of these dating apps and all of these instant messaging tools, which were integrated everywhere, they had to move their infrastructure to Kafka.
Right.
Okay, let's see if this would work. If this gives us trouble, then I'm going to ask Pawaz, and we'll use the half an hour or 1 hour of our 3 hours to meet again and install Hadoop from scratch. Okay, in the meantime, let's go to the Jupyter notebook and let's do the PySpark. Let me send you an example for that.
Okay.
So PySpark is going to run in a pseudo distributed mode, which means that when you install it on your computer, it's going to, it's not going to bother us for anything. So 1 second. Okay, I'm going to, in the meantime, let's see. Otherwise, I'm going to show you on my side. Okay, let me see what's happening with Cloudera. Submitting jobs, starting. Okay, if you want to check, you can open your browser again on the Cloudera server, and you can see if it allows us to go to the, yeah, or you can click Cloudera Home, or the second thing just below the computer, the second button.
Oh, this one?
Yes, Cloudera Home, that should also work. Okay, yes, let's try to log in. Cloudera. It's going to take us to a panel which is going to show us the status of SDFS, Yarn, Hive.
And this is manager, right?
Yes, this is the main reason.
Okay.
Okay, we are in. You can click on remember.
Okay.
Okay, now if you see on the left, these are all the tools that they gave us, and some of them are essential to start Hadoop. For example, the first thing that we have to start here is Hadoop file system. So if you, and it tried to start something, but if it's not able to find resources, it gives up. And that happens when you don't give it enough RAM. So click on the drop down in front of Hadoop file system. On the left, third one on the left. So host, HBase, HDFS.
Okay.
So do you see HDFS? Or you can do a control F and search HDFS, yes. And then you can click on start.
Start. Okay.
Start, yes. So the first step, and then you can click on start. So this is the first step, which is to start the Hadoop file system. That's the elementary step. If the Hadoop file system is not running, which means that we cannot access any file from the Hadoop server.
Mhm.
Now, when the Hadoop file system would run in a distributed manner, this is just one computer. But when it's going to run on the distributed manner, and if like one of your node is down, or if it's not able to connect to one of your nodes because of some security issue or like SHA keys or something, this point, it's going to raise a trigger that, hey, I was not able to contact to this node or this node, or I was not able to find the data here, or whatever trouble that is going to be with the file system, it's going to show us. Okay. Now it says that I started services waiting for name node to begin response to RPCs. I forgot what it RPCs, but name node is the node which takes care of all the worker nodes. So, okay, so the name node completed and Hadoop file system is started. You can click on close. Now, all these commands we have to run in Ubuntu manually when we run it manually.
Okay.
Okay. Now, the next step is you have to start the Yarn operating system, which is the second last on the screen on the left. Yarn, Y-A-R-N. You can also do a control F and search for Yarn. Yes. You have to start. Yes. This Yarn operating system is just the next layer of operating system. The full form is yet another resource negotiator, but
Okay.
this is the way for like tools to talk to Hadoop file system. Now, there are two ways to think about it. We could skip everything and Hive could just go to the Hadoop file system and talk to the Hadoop file system, right? But the problem with doing that is that we have limited resources in terms of CPU and RAM on all these computers. And if we don't manage them properly, then Hive wants to get something from the Hadoop file system. HBase wants to get something from the Hadoop file system, and we would have nobody to manage that.
Okay.
So this thing is like an operating system. It manages all the resources of the system. Okay, you can click on close. Okay, now, oh, you see that exclamation mark on Hadoop file system? Can you click on it? It's going to say that, yes. We are going to ignore it for now, but this is because we don't have enough RAM and things like that. So it's going to say that, oh, I'm not able to connect to this and that. For now, let's ignore it.
So is it possible now to change the RAM?
It's going to take like 10-15 minutes to start. So we'll do it the next time. We'll cut this short at like 9, and then we'll do another hour, maybe Monday or Tuesday.
Okay.
Now let's start Hive, which is just below HDFS. You have Hive. Yes. Yes. The most common step in Hive, which is also in the tutorial, is to move something from SQL to Hive or MySQL to Hive. So that's like the first exercise to understand what Cloudera does. And a lot of work was done to move the old SQL data to the Hive. And of course, in the future, they are going to use only Hive and they're not going to use SQL. Okay, in the meantime, you can open another tab. And in another tab, you can click on Getting Started from the bookmark menu, which is the last bookmark. Getting Started. Yes. Yes. So, and so if you see, they have 3 steps. The first is understanding Impala and this and that, analyze your data and manage your cluster. Let's look at the first one, Getting Started, and click on Start Tutorial. So they have an exercise. They already configured. By the way, it's also running MySQL. That's why this is so resource intensive. Not just it's running a lot of Hadoop stuff. It is also running on the back end MySQL and other stuff. And that's why this computer is very resource hungry. Okay, let's click on next, getting started. Okay, now these are some scenarios which are also good to talk about any experience or any learning that we did. And they're saying that a company had like a lot of data and they want to move it from SQL to Hive. I'm just cutting short the story. Now you can go to tutorial exercise 1. Okay, if you see, this is like the relational database, one-to-many relationship, foreign key, private key, foreign key and public key, and those kind of stuff.
Okay.
And you can use this in MySQL to create all this relational database. If you scroll down, yes. Now, if you see this command, scoop import all tables,
Okay.
and it says that use this JDBC driver, use the database called retail database. The username is retail_DBA, password is Cloudera. This compression code is the way of compression on Hadoop file system. They always ask in the interview that which compression codec do you use or what is compression in Hadoop. If you just say that you have heard about Snappy, you never went into detail, that's good enough. They just want to know what is the compression technique. You can read more about it. I read it about, but frankly speaking, I never even use it on a daily basis. So,
Okay.
but we have to use compression codec so that we can compress the data when we store on the Hadoop file system. Now, Parquet file, there are two types of file in Hadoop file system. One is Parquet and one is Avro, AVVRO. This Parquet file is used to store SQL database and Avro file is used to store NoSQL database. So they ask you, how do we dump these things on the Hadoop file system or how do we store it? So on the Hadoop file system, all structured data that is coming from SQL is stored in a format called Parquet format. Then this is the warehouse. This is the location on the Hadoop file system of the data. And then this is the import. Now, to make this work, what all do we need to run? Since we are going to use Hive, we have to run Hive. Hive server should be on. The SDFS server should be on. And Scoop should be on, right? Because this is a Scoop command. That's the first keyword. So Scoop is a tool which is very similar to scooping an ice cream. It takes the ice cream or the stuff from SQL and put it into Hive. So it scoops it. It scoops out all the nice things and put it into the big data world. Okay, now let's go back to the third tab and let's see if Hive is started. And then we are going to start Scoop and then we are going to try to run this command.
Third one is Hadoop.
No, in the same tab, the third tab, we don't need to open a new page. The third tab is already there.
Oh, is this one? Okay.
Yes. Okay, so it started. Now just remember, if there would have been a problem with Hive, with Yarn, or with Hadoop file system, this guy would have said, no, I cannot start and I don't know why. Because this Hive is going to talk with the operating system. Like for example, if your operating system is not on and you try to run Chrome or call Chrome, then Chrome is going to say, hey, first you have to start the Windows.
Okay.
Windows is not started. And even before the Windows is started, you have to input the hard disk in your computer. If the hard disk is missing, it's going to say, forget Windows or Chrome. The hard disk is not in the computer. How can I start Chrome? So this one is done. Now let's start Scoop 1, which is the fourth last thing on the left. So you can click on close for this screen.
Oh, okay.
Uh-oh. I think you closed everything. No, you did not. Okay. You can go back to the yeah. No, close. Click on close on the or cancel. Yeah. Now
Okay,
let's start Scoop 1. It's the fourth last on the screen. Yes. Scoop client action. I think it's already registered. It's already started. Okay. So everything is done for now. We're just going to run the command and see if we get an error or something. Now this is your configuration of your grid, which is cluster disk. This is the combined space in the cluster and so on and so forth. This tool is managed and developed proprietary by Cloudera. It's their tool. And that's why they charge money, because they developed this tool. But HDFS is open source, Hive is open source. We can create this tool on our own, which we generally do in the bigger course. We skip Cloudera and we install everything on our own. And the command that you use to start Hive and Yarn and everything, we write a manual command to do that.
Okay.
So
this
these guys,
scope,
yes.
when we are using this, and they will charge, right? Scope.
Yes, if you're using this Cloudera, this GUI, because they did all the hard work to put it together.
Okay. Okay.
But it would be some other tool. If you're using Amazon, they also came up with that where it's called Elastic MapReduce and so on and so forth. This one is very easy and quick. So I prefer this because Amazon charges you accidentally money. And if you don't take the premium account and give your credit card detail, it asks you money and it's a big mess. So I don't want to. And Amazon takes 24 hours to review your account and pass it before you can use it.
Okay.
Okay. Now we are going to, everything is good for now. Now we can run the first exercise. So let's go back to the fourth tab, the tutorial tab. The fourth tab on the screen in Firefox, the Cloudera Live Welcome. Yes. And let's copy this code carefully from scoop all the way till end. The first code block. Yes. Yes. Right click and copy because Control C might not be working.
Okay.
I did not see you copying, doing right click. Did you do that?
Oh, okay.
Right click and copy. Yes. Now we are going to paste it in the terminal. So let's go to a free terminal. I think I see two terminals open. You can use either ones or you can open any one. Yes.
Yeah, we can use this one, right?
Yes, we can use this one as well. You can use any. You can use a new, you can use old. Okay, you can right click and paste it. And let's look at this tab. If everything goes fine, we are going to see the tables being created in Hive. And I'll show you how to go to Hive and check these tables.
Okay. And how to run this?
Oh, you just press enter.
Oh, okay.
Okay. Now it's going to run scope and everything. It's going to import the data. It's going to run the SQL commands. It's going to store everything into your Hadoop file system and so on and so forth. This is the first step. The business case was, and I'm taking many steps. I'm like telling you the summary of 2 pages from the tutorial. There is a company, they are storing everything in SQL database. You are a Hadoop analyst or a Hadoop developer. They called you in and they want you to move all that SQL data into Hive so that they can use it in PySpark or run machine learning on it or whatever they want to do. And in the future, that the data is going to come directly into Hive through Kafka or some other streaming service.
So this step is like gathering the data. What is this?
Yes, this step is migration from SQL to Hive.
Oh, okay, okay.
And it's going to run at the back end. It's going to run MapReduce. Can you see on the screen MapReduce.job? Info MapReduce.job on the screen. The last 2 lines. I see a lot of MapReduce. You see
Last
that?
oh here, okay.
Yeah, info MapReduce job, running job. So these are all jobs, and they are MapReduce job because they are at the computation layer.
Okay. Okay.
Okay, in some time, if everything goes fine, and I don't see a reason to anything to fail, and then we are going to start Hue and go inside and see this data on the Hive.
Okay.
So even the simplest command, select star from something. By the way, you have to start Hive before we use it. So on the left of the screen, you have to start. Sorry, Hue. Yeah. You have to start it. So going forward, all of the data is going to be stored in Hive and no SQL most of the time. That's why suddenly they had a big demand of these big data people. And the problem was whoever were using SQL, they were not upgrading their skill and writing Hive in their resume and everything. And a lot of time people would just say, no, I don't know Hive. They don't even say that I have done a small project or I know it for 3 months or 6 months. They would just outrightly say, no, I don't know Hive. I don't know Hadoop. I don't know Hadoop file system. I don't know Scoop.
Okay.
But you can always defend a 3-month project. Like in my current job, yes, I did a migration for them and I showed them how to migrate that.
Okay.
Or like I convinced my current employer that let's keep this thing in open, or I want to do this project for my self-development. I talked to my manager. Okay, you can click on close. And you can open a new tab, and inside the new tab, you can open Hue, which is the second bookmark.
Is it wrong? Is it right?
1 second. Yes. So it should have started. I don't know why it's not starting. Yeah, click on Hue. Yes. Oh, it did not start. Let's go back to the Cloudera Manager, the third tab, and see what's happening. Hue is started, so it should not bother us. Okay, let's go. No, that's right. So let's go to, in the meantime, to the terminal to see what happened with the migration. Okay, still running.
Where it is? Here?
Yeah, it says running job 15982 underscore 0. It's still running.
Okay.
Okay, let's try to start. Let's try to start this Zookeeper,
Uh-huh.
the last one. Maybe that's going to help. And then let's try to open Hue again. So let's start Zookeeper.
Okay.
The Zookeeper, as the name suggests, they call it Zookeeper because it takes care of all the animals, and they consider this hive and HBase and everything as animals. So if these things are talking to each other, then Zookeeper helps them talk to each other. And this OZ is to run automated tasks, like if you want to run something in the morning, in the evening, or something like that.
Shall I start something here?
Oh, start a role. No, that's it. I think that was, yeah. No, I think it's okay. Yeah, I think it's okay. I was wrong. Maybe Zookeeper is not required for now. Let's go to the screen and try again to open Hue, and let's see if that works. Oh no, on the browser. Let's open a new tab. Oh, I see Hue Editor, the second tab. It's populated. Can you take me to the second tab on the Firefox?
Yeah, it's coming.
Yeah, it's working. Okay. Shift from Impala to Hive. So on the query, do you see that query? And there is a drop down. If you click on the drop down beside the query,
Oh,
it's
yeah.
going to allow you to change to Hive. So can click on the drop down, yes, and switch to go to editor and switch to Hive. Now this Impala is made by Cloudera guys. Therefore, they think that it's better than Hive. So
Okay.
okay. Now, can you reload this page? So if the migration was successful, we are going to see the table, that retail table on the left. And if the migration is not successful, it's going to throw us an error and tell us why it was not successful.
Okay. So here SQL means from which SQL it is?
From MySQL.
From MySQL. It is inbuilt?
It's inbuilt. It's with the operating system. Yes, the MySQL.
Okay.
There are few small projects on this one. One is this, and the other one is PySpark. If you go through them, then you can easily define like some small projects. Whenever somebody asks you if you have done something in Hadoop or something, like simple migration from MySQL to Hive, and how did you do that? You use Scoop, like you had to define the compression type, you had to define the file type, which was Parquet and all those stuff. And you can at least define something to show that at least you have given these kind of thing a shot when you go for any job interview or something. If they dig deeper, you can say, no, I did not go into detail because that was just one project. If you were to independently study small things, then you can study about more about compression technologies, and in Hadoop, you can study about, okay, there is no table maybe. Because that migration is still running. If it works, then we are going to see the table.
Connected to Meta Stories.
Yeah, so it is working because once it does it, it's going to end and say that transfer complete.
Okay.
So in the meantime, let's switch to the other screen, and I want you to go to on your main computer. I want you to go to Google and search for creating PySpark data frames using raw data. Creating PySpark data frames using raw data.
You want me to type it
Yes.
in the chat
Yes.
section?
Yes.
Okay. What is that one?
Creating PySpark data frames using raw data. Yeah, from list, even that would work. Yes. Creating PySpark database from list.
Again, I have to type it, right?
No, after data frame, you can write space from and
List.
yes. Yes. Yes, and you can open the first link in new tab.
Okay.
I have my notes. I have to email you them.
Okay.
Okay, and let's go. Now, all PySpark data frames are, or for that matter, anything like that is a distributed object, which means that whenever you want to use them, you have to collect them. And you cannot collect a big distributed object because you don't have enough memory and space on your computer, right?
Mm-hmm.
So you're never going to collect any distributed object unless you run an operation and make it small enough, condense it small enough, or you run a reduce step to make it small enough. Okay, let's scroll down. Okay, let's try to run this command. Yes, this one. Let's
Okay.
copy this whole block. Yes. Yes. And let's paste it. And I'm going to show you. Now there are two contexts in this. Mostly we use the SQL context because it's easy for us to populate anything. Yes. And then you use Shift Enter. And let's see the error that you're going to get. If the PySpark is not installed or if something crazy is happening, then we're going to get
PySpark is already installed.
okay, so then it's going to work without an error.
Right.
Now, in all Spark data, okay,
Spark is not
Spark
defined.
is not defined. Where is the Spark? Okay, can you copy df is equal to schema? Okay, schema should be C schema. Okay, and skis. Okay, can you copy this line and search it on Google? So select this whole line, name error. Double click on that line.
Which line?
This name error.
Oh, name error. Okay.
The whole line, and then right click, and then click on search Bing. There is an import issue that Spark is not defined.
Mommy, look at this.
Yes, yes. This is how we solve the problem all the time. Okay, you can click on the first one. We only use Stack Overflow.
Right.
So they call it the stack. They call us the Stack Overflow engineer or model engineer, all model engineers. Okay, let's see the solution. Let's go down. I can pick the solution already because I already know it. If you scroll down, yes, wait. Since you are creating data frame, you need to do create data frame, data and features. Okay, instead of SQL constant, instead of Spark.create. Okay, okay. Let's go back and see which thing did we use to create Spark data frame. What was the name of the context? Otherwise, we have to create a Spark context.
This one.
So when we did Spark dot thing, we have to create a Spark context and use it. So can you go back to the page and they'll show us how to create a Spark context. Yes. No, the error, name Spark not defined. So the last tab on your screen.
Mm-hmm.
Can you go to the last tab and they're going to show us how to import a Spark context and use the Spark context. The Spark context is going to point to the Spark session. And at one time, we can just use one Spark context. So if you go to the last tab on your screen. Yes. And let's say scroll down and let's find out the place where they created Spark context. So go down. SQL context dot. Okay. So copy that SQL context in the code. df is equal to SQL context. Yes. Only use SQL context and not Spark.
Okay.
Yes. In place of Spark in our code, we have to use SQL context.
Only SQL context.
Yes. And I think we are using Spark. If that does not work, we are going to import SQL context. I think we already imported it.
Yeah, it's already installed.
No, we never imported SQL context. So let's remove Spark and write SQL context.
So shall I test it here?
Yes, yes. You have to remove Spark and yes. Yes, and we might need to import it, but let's find out what happened. So press Shift Enter. Okay, now you can copy and search this line on Google.
Which one?
The last line, name error. Name SQL context not found. So you can select it, right click and search. And it's an import statement. Import PySpark from something from SQL context. Yes. Yes. Let's click on the first one. Yes. And the first line from PySpark import SQL context. Yes. We only need the first line, not the second.
Okay.
And we are going to put this on top of this line. Yeah, before this one. So you can move this up using the up button. Yes. Yes, and you can, yes. Now press Shift Enter and Shift Enter. Okay, and in place of SQL context, can you write Spark context? Because we are importing Spark context. Oh, no. Go back to the page. I think we copied the wrong one. If you can, you go back to the page where we copied this from? Because we copied Spark context. It should be SQL context. Can you go back to the page?
Here?
The page where we copied this from? Yes. No, not this page. The page where we found the error.
Here.
Yes, now let's scroll down. Scroll down. Let's scroll down. Yeah, there it is. SQL context. So can you copy this 2 lines? Yes. Yes. And this should work. Yeah.
Okay. So completely.
Completely remove this line and put this one. But again, SC is not defined. So I don't know this is going to give an error. But let's run it. No, you cannot. Okay, let's try to run it. Okay, data is missing. Create data frame. Okay. Okay, I think what the error is. Let me share my screen and show you how to resolve these errors.
Okay, yeah, sure.
1 second. Exit full screen. Oh, how would I get that? Okay, can you make the host again?
Okay.
Or reclaim host. Reclaim the host now.
Right.
Okay. So let's quickly do this. Create Spark data frame from list. Okay. What happened to my Jupyter? Okay, this is my Jupyter. A new file. I'm going to use Anaconda 3 environment, paste it here, and run it. And it says Spark is not defined. Going to quickly Google this. And it goes here. df is equal to sparks
Steve,
or
you can
prime
Sorry.
data frame. See. Okay, I'm going to use and I'm going to copy this block, move it up. And then I'm going to do df dot show. We can also convert pandas data frame. Have you used pandas? Rama, can you hear me? Have you used pandas?
Yeah.
Okay. Okay, let's see. Yeah, so this is the data frame.
Okay.
So what we have to do is we have to import the Spark context.
Can you put it on chat windows?
Yes.
So
I'm
I'll
going to
paste
create
it
the
and
So this is step 1. And once we have that ready, this is step 2. And I'm going to email you this slide as well. Okay. But before that, the Spark context is whether we are running it locally or in a distributed mode and those kind of stuff. And whenever we run something, we have to define a context. And at one time, we can use just one context. Now, once these things are in a database, we can select a column or do whatever we want to with that. I would suggest you to use the PySpark cheat sheet. Let me show you. Cheat sheet. Yes, I used this one. I'm going to send you this. I learned from this one many years ago. And this cheat sheet, and let me invite you to my Nehal, after the session, please invite Rama to the Slack channel. So I have 2 Slack channels. One is Python and the other is Hadoop Big Data. Where is my Hadoop channel on Slack? Okay, Nehal is going to invite you to my Slack channel. In the Slack channel, we have the conversation going on. This is the Python one, and then I have another one for big data. So let me invite. Rama, can you? I have your email, right?
so or I can put the text.
Yeah, if you can text me. Okay, I'm waiting for your text. I'm going to invite you to my Slack channel.
Right.
And I think I don't know why it does not come into my history, but I have another Slack channel for Hadoop. Okay, coming back to my cheat sheet. So this is the cheat sheet. This is one of the best one. This is the first 2 steps that we were missing, if you remember.
Oh, okay.
Spark context. So Spark context is, as the name suggests, context is it is local. It's going to run in pseudo distributed mode. We just install PySpark on Python. We don't really have a cluster. We don't really have a Hadoop file system. We don't really have a yarn. So we wanted to like skip everything and just use it. Now, all the sparks, and then of course we can define the context because we can define the kind of memory we want to use, the name of the application. Okay, Nehal gave me the other channel of big data as well. I'm going to invite you there as well. I forgot it. Ideally, we invite everybody before the session.
Oh, okay.
Okay. And these things we don't really want to run. If we want to install the PySpark manually, then we are going to run this thing. The more important stuff is this RDD. Now, RDD are called resilient distributed data set. They are similar to a Python list, but just understand why they are called resilient and distributed and data set. They're called resilient because they create mirror copies of themselves. If you remember, there was a distribution factor and a replication factor when we store data in Hadoop. We replicate the data on different computers so that if one of the computer is not working or slow, we can use it from another computer.
Mhm.
So that's why they call it resilient, because it cannot be destroyed easily. Even if one or two data nodes get destroyed, or if the hard disk get destroyed of few computers, we can still get it. And distributed is because whatever is our distribution factor and Hadoop file system is going to honor that. And D is for data set.
Okay.
And whenever we create this RDD, it gets stored on different cluster. It's not stored on our RAM. So imagine if I say, if I just write something like this, X is equal to, and I say a list in Python, right? This X is stored in my RAM. But whenever we do RDD, it is stored in the cluster so that we can handle big data. So that's the
Okay.
RDD. And they are called parallelizable connections.
Mhm.
You can also get any data, like a big streaming data or a big image or big, if you want to do any video recognition, image recognition, then we can get a video file and store it. Now, as I told
So,
you,
yeah, I have a question. Now we have the Spark and the, Python Jupyter notebook, right?
mhm,
So, like, how they're doing on the Hadoop system, similarly we can do here, right?
yes. So there are a few things that we do on the Hadoop file system. We replicate data on the cluster, and we also have a factor where we distribute it, right?
But thing is, here we can't do all the SQL kind of like Hive kind of things, right?
Yeah,
So,
on not in PySpark. We can do it in a pseudo distributed. It's like a fake distributed now. So we're
okay.
just doing in this practice. Imagine if this Spark, when we are going to run on your Cloudera, and
Mhm.
you're going to write this fc.parallelize, it's going to use your Hadoop grid.
Okay. Mhm.
But right now,
So,
since we are running into a pseudo distributed mode, it's just going to use your computer.
okay. So here we can get the data, whatever the finalized data, then further we can do the analysis part.
Yes. So whatever data that we get from Hive, if you remember, we moved that. Let's go to the, oh, but that's on your computer. So we moved the data from MySQL to Hive, where we were trying to move, right?
Mhm.
On the cluster. Once the data is on Hive, from Hive, we are going to bring it directly to PySpark.
Okay.
And then we are going to perform any function that we want to.
Mhm.
We cannot bring that data to a pandas data frame or any other place, because if we do that, then we cannot then it's too big to be stored in the RAM. So we can only create a distributed object and use a distributed object.
Okay.
So if so, let me show you a simple example like they are showing us. If they say that sc.parallelize, and they gave us this example, if you see the first one, A7, A2, and B2, if in place of this there were like billions of rows, billions, so that you cannot store it into your computer, then we would write sc.text file, and in place of pointing to this, we would have written hdfs colon and the IP and everything of the Hadoop file system. And it's going to take that file from the Hadoop file system, which is like 500 GB, and store it into another distributed object, which is called RDD. So we are working with two objects that are itself distributed on the grid, which are not on our computer. But right now for practice, whatever we are doing, so right now for practice, this DF is on my computer. But when we are going to actually run this on Cloudera, the virtual Cloudera, or on an actual machine, great. This is going to go to the cluster. You can still ask me the same question if you have any doubt.
Okay.
Nehal or Paras, do you want to talk about the same thing in a different manner on what's happening here? I don't even know if they are there.
Hello.
Yes.
Yes, sir.
So when we are creating an RDD, we are creating a distributed object on the Hadoop grid. So when we read a table from Hive, which might be 1 terabyte, 2 terabyte, 3 terabyte, I cannot store 3 terabyte on my computer. My hard disk is only 1 terabyte. So what if the size of the table from Hive was 2 terabyte? So what I'm going to do is I'm going to start my Jupyter notebook and do the Spark context, and in place of local, it's not going to be local, it's going to be the actual Hadoop cluster. And then I'm going to configure and say that my master is not local. My master is actually the name node. And I'm going to configure this. And when I run this, all these RDDs, all these variables are going to be stored on the grid. So I can say sc.parallelize and I can point it to the Hive table. So that 2 terabyte table is now stored in RDD, which is again stored on the Hadoop file system in the memory. This RDD is in memory. So this is stored in the memory of my cluster.
And sir, when we use local, when it is in data node, like many computer. For
Yes,
name
but-
node, we use master.
Yeah, if we right now we are doing local because we want to run on one computer, my computer. But if you want to run it on the grid, then in place of local, you're going to use name node. And you see this memory is the memory of the grid. So right now in my computer, if I have 16 GB memory, I can say that this application can use 1 GB. But when we are going to use the grid will have a lot of memory because each computer will have like 32 GB. And if we have like, I don't know, if we have like 30 computers, we will have like 100 GB of memory. So out of that 100 GB, we can say that, okay, give 10 GB to this thing, or give 20 GB to this, or give like 30 GB to this. Because I have only 16 GB, I cannot give more than 16 GB on my computer. But if it's a grid, I can, and this thing is going to use the grid, so I can say that, okay, give 100 GB of memory to this app. So I can take a 50 terabyte table on Hive and put it into a Spark object or a Spark RDD, which is going to use the grid memory and store everything on the RDD. Rama, if it's getting too tricky, we can continue it next time, another like 1.5 hours the next time. You want to do that? Or you want
Yeah.
to?
So next time means like we are going to stop it here.
Yeah, we can start from the same place and do the PySpark the next time. And
Okay.
we can do 1.5.
PySpark it's okay, but I did not get any like idea about the Hadoop system.
Oh,
I'm not theoretically we got it, but
oh, do you want? So we have 2-3 options. Either we can do more of PySpark, which is this, or we can do Hadoop installation. Do you want to do Hadoop installation the next time from scratch?
Hadoop installation means whatever I have it on system, that is okay, right? Or,
Yes. Yes, but we can install Hadoop from scratch. Yeah, you can tell me what you want. In the next session, we are going to talk about.
no, like whatever the data processing or streaming. So how industry people will do taking the big data and processing the big data in the Hadoop system, and how they're making the pipelines in the Hadoop system. So I would like to know that path, like. So, but we haven't we started the machines. And,
okay. So for that, we have to use Cloudera. So we would skip this and we would have to jump to Cloudera and create. So one of the pipeline was that Scoop. So you want to do something like that, right? Moving data from the
right.
Okay, got it. So let's I'm going to give you the control for the next 10 minutes. Let's try and see what's happening with the scoop movement,
Sure.
and then we'll focus more on the movement of data for the pipeline. So
Okay.
let me make you the host again. Yes, I made you the host again, and let's see what happened with scoop, and then we are going to focus
Right.
more on movement of data. So you have to share your screen.
Mhm. I think it is here.
You have to go to the cloud era. Okay. Then we have to go to the terminal and find out. Okay, everything was successful.
Mhm.
So it retrieved 1345 record. Now let's refresh the queue and we should be able to see this table. So if you go to the queue right now, the second tab, yes, you see there is no table on the left. Let's try to refresh this page and see if we can find the table. So refresh this page.
Refresh. Where to refresh?
It's at the end of your address bar on the right, the refresh button. It's left to the
Oh,
search.
here. This one.
Yes.
Okay. Not connect to Kickstart Cloudera. I don't know why.
I think it's going to refresh. Yeah, maybe the connection got
Okay.
lost.
Mhm.
So there are two steps to this. One is moving something from MySQL to Hive, and
Mhm.
the other is moving from Hive to MySQL.
Okay. Okay.
And in the pipeline world, there is moving from Parquet to Spark Data Frame, because whatever is in Hive, you see there are new tables. On
Yeah.
the top. So these are the
These are-
tables that got.
Oh, okay. So we have used this. It is.
Yeah, the scoop. So
Where
we use the scoop.
So somewhere we have used the Hive, right? So
Yes, if you go to the last tab,
this one.
yes. So this
This
is
is
the command that we use.
the command we used, but
Scoop.
where did we kept this one?
Oh, we ran that command on the terminal. So
Okay, on the terminal, not there is no specific
no. We
thing
have
for
to run
Hive.
that.
Okay,
Yeah, that's
okay.
a
We use the command terminal and we ran the code.
yes.
So then it is displaying here like.
Yes. So it took all the tables and it moved it to the Hive.
Okay, got it.
These
Okay.
are the data pipelines that they use to move data here and there.
Okay.
The
So
next step is to move from Hive to PySpark. That is the next tutorial, but it's a little long one. But yeah, that's the next tutorial. So let's go back to the tutorial. And these are data pipelines of moving data
okay.
from registry. And then after that is moving streaming data, which means that a chat window, people are talking and sending message to each other, and then you stream it and store it. Okay. The next command is if you want to see these files in the Hadoop file system, then you have to run the next two commands. So let's quickly run the next two commands.
These two.
Hadoop FS, yes. So FS stands for file system, LS stands for list, and this is where we store all the data. And what is the format of data for Hive? It's called Parquet, and the compression is Snappy. Yes, you have to right click and paste. Yes.
Shall I do both at a time or one
No,
by
no, one by one.
Okay.
So now it's going to show you where the data is stored. And you
Okay.
press enter. And this is where the data is stored on the Hadoop file system.
Okay.
So this is on the grid.
Okay.
You see, these are the files that we got stored, and this is the location and when they were created.
So kind of verification, right?
Yes, this is for verification, whether we were able to move things from SQL to this. Yes.
Mm-hmm.
Mm-hmm. Yes, this is the metadata and all the other stuff.
Mm-hmm. Okay.
Okay, let's scroll down and see what is the next exercise, and we would do that probably the next time. And you can also try this on your own. and
Oh, sure.
find
Okay,
it is
okay.
where you get stuck. So let's
Got
scroll down. Let's scroll down. Okay, we already did this. Scroll down. We already did this. Scroll down. We already, yeah, we can run this invalidate metadata and show tables if you want to run it. So you can do this on your own. This is easy. All you have to
for
do
that,
is,
we have to use Impala.
I prefer Hive because Impala is Cloudera, so nobody is using Impala in the back.
Oh, okay. Okay.
So, but the commands are same. So you have to write show tables, invalidate metadata, the thing in purple you have to write.
Okay. Mhm.
Okay, let's scroll down and let's see what's the next. Okay, wait. So this is the way to run a query on Hive.
Uh-huh.
So you can copy this command and run, and this is a Hive query. You see, it looks very similar to SQL query,
Right, right.
but actually
Yeah.
it's a Hive query. So you copy this, you go to the Hive editor, and you run this query.
Here only,
Not
right?
here, the Hive editor on the screen.
Oh, Hive editor. Did we open that one?
Yes, this is the Hive editor. No, that's the Hive editor. You were there. Copy it here on the screen.
Oh, okay,
No, no.
okay. Yeah.
Yes. Yes. And you can click on play button on the left. You see a very small play button in blue on the left of the code. Yes.
Mhm.
And this is querying it from the Hive, not from MySQL. We can also start MySQL and query it, although they did not give us the code to do that. But we can dig deeper sometime if you want to. Now, all these jobs at the back end run as a
But
method.
earlier we used we used this one, right? What it is called
The
terminal.
terminal? Yeah,
Yeah.
whenever we want to run scoop, we use terminal. But when it's a Hive command, then we use Hive terminal.
Oh, this the initial what we gave the command here, that is
That was a
right?
scoop command. Yes.
Okay. But how to know that this is scoop or not?
Oh, it's written scoop. If you go to the thing, if you go to the tutorial, there is a $sign. If you go to the fourth tab on the screen, no, on the fourth tab, yes. And if you scroll up, you see it whenever it's a shell command, it's going to show a $sign. You see that $sign?
Uh-huh.
So this is a
Okay.
shell command to be run on top.
Okay. Uh-huh. Okay.
And if you just write scoop on the terminal, it's going to show you what all scoop can do and what all commands scoop has. So just write scoop on the terminal. It's going to show you. No, just scoop, not everything. Just scoop. SQOOP. Just write this on the terminal, and it's going to tell you, hey, you did not give me any arguments on this and that.
Okay. Uh-huh. And Hive editor
No, not in the highway. On the terminal.
on the terminal. Okay.
Yes. And if you press enter, it's going to say, you see, it's trying to run scoop, but we did not give any arguments. It's going to say, hey, you did not give me any arguments. Why are you trying to run me when you did not give me any arguments?
Okay. Mm-hmm. Got it. Yeah. And again, to start the quick start, what we have to do here? Okay, it's automatic for me.
Yeah.
Okay, right.
It did not do anything. Yeah, to do the quick start, you have to go to the desktop so you can minimize everything.
Okay. And I think it's still running or done?
It's still running because the computer is slow. So
Oh, okay.
the thing is, it's running so many services.
Mm-hmm.
It's running Hadoop file system service. It's running.
Okay. So
the time and everything. If you minimize everything,
sure.
so minimize this, minimize Firefox, and that launch Cloudera Express. Yeah, so we ran this command: sudo home Cloudera manager force, and after that we wrote Express.
This one, enterprise.
No, the one on the top. Express is free. Enterprise is money.
Okay. So shall I open this?
Yeah.
Mm-hmm.
Coming. So we wrote. So we ran it by sudo. We copied this command.
Which one I have to?
The second last line: sudo home Cloudera manager.
Oh, this one.
Yes, this is how we start Cloudera.
Right. Okay.
So when we start Cloudera, after using Cloudera, we can start Hadoop file system, we can start YAML operating system, we can start
So,
anything that we want.
okay, this one again, I have to type it in.
Yes, in a
terminal.
new terminal. Yes. But it's already running, so maybe it's going to give you an error or something. Yes. But this is tomorrow. If you start your computer tomorrow, you have to do this step.
Oh, sure. Okay.
And you have to write express at the end.
Oh, Express.
Use the up button from your keyboard. Up, down, up button.
Oh, okay. Okay.
If it's not working, you can paste. Yes. And space dash dash express. We forgot to write express.
Okay. Like that.
It is going to start. Once you start this, then you have to start Cloudera Manager and you have to start all the services you want.
Mhm. Okay. Remember this one.
Okay, you can go through the tutorial and we'll continue from here and we'll see how to create the Spark pipelines, how to get data from Hive and the files and move it into Spark.
Okay. So this 57, like we have submitted this 57 or somebody like in the.
Oh no, these are these guys, these Cloudera guys.
Oh,
They
okay.
are running all the services because they want to come up with that GUI so that they can run everything for us.
Oh, okay. If suppose some company like industry, if they want to use the Cloudera, will they have any separate private domain like the Cloudera?
I think so. Yes. Because we will only expose the Hive ports to the user to run it. So this is admin stuff. What we are doing.
Okay, got it.
For the user, we are going to just tell them an address where the Hive page is going to open. In fact, you can do that. If you go to Google on your main computer, go to Google on your main computer and search for Hive, practice Hive.
Sorry.
You write practice Hive. It's going to show you a Hive page, which is for the user. Once we configure it. Yes. Enter. Yes. And click on the third link, that demo.gethue.com. Yes. No. Down. Demo.gethue.com. The third link.
Third means.
The Hue. Welcome to Hue. That one.
Oh, here.
Yes. So this is what the user is going to get exposed.
Okay. Again, the same one?
Yes, Cloudera. Yeah, demo. Yes. So this is how we'll expose the user, because user will not have the rights to play with a lot of stuff or start anything.
Oh, okay. Okay.
Okay, so these are the practice sites.
So just for my idea, just again, I'm like to see once again in the Cloudera thing. Sorry. So what we have to do, so using this query, like whatever the SQL or like similar to SQL.
Yes.
So we have to get the data from the MySQL into the Cloudera system.
Yes, for that we use Scoop. So now the data is in Hive. So, and these are Hive queries to query Hive tables.
Okay. So we ran the query on Scoop, and then the tables, like what are the database are generated, stored in the Hue, right?
And the Hive. Hue is just the front end, the GUI tool.
Okay. Oh, it's in Hive. Okay.
The Hive.
So, okay, you already explained in the beginning, but so here, why it is showing the Hive in the this domain? Like,
Oh, because Hue allows us to use Hive graphically. Otherwise, we have to use it on the command prompt.
okay, got it. Okay. So here the tables are ready. We can do whatever, like based on the requirement, we can arrange or redo the making the in other databases using the HQL, right?
Yes.
So here, and once the database are ready, then what we have to do? So suppose like further.
Whatever the query is, we have to just check the query and generate the output.
Mhm. So from here, what we have to do these data sources?
Oh, these are the Hive tables, and they are big tables. So we have to condense them and give the user whatever they want. So when we do group by, it groups everything and it takes the count. So there might be, you see all these counts.
Oh, just a second. My son is making noise here.
Okay. So whatever we want to do, any SQL query on the big data, first we have to bring the big data into Hive, and then we have to write these Hive query to do the same calculation. Now the query that is in front of you, if we would run the same query on SQL, it's going to take like 100 or 200 times more time.
Okay.
Because this query that is on your screen gets run using MapReduce.
Okay.
So if you dig deeper into this query and you observe when you run the query, it's going to show a rocket sign, and then you can see that it's creating the MapReduce job 1, job 2, and so on.
So
This
here,
query-
yeah. Sorry. Yeah, Karen.
Yeah, this query is to run the SQL query on the distributed table. Those tables are not on one computer. They are on the Hadoop file system, the distributed database.
Okay.
So to read them is like 100 or 200 times faster than reading a SQL table on one computer. So, and you cannot store like terabytes of data on SQL. So it has a limitation and it goes very slow. So this is how to query a Hive table.
Here the tables are ready, right? So from here we can use it in the Spark from here in the cloud system.
Oh, no. That's a long process. It's in the tutorial.
Oh, okay.
In the tutorial. For that, we have to run some commands from the command prompt to move this Hive table into PySpark. So let's go to, you can go to the tutorial, the 4th tab.
Okay.
And you can read it, and we are going to do it the next time.
Okay.
And it also has an example of Kafka at the end. So whatever we can do. It's a time taking, but the idea is if you scroll down, we already did this. We already did this. We already did this. We already ran the command and we got the same output. There are some more commands they want us to run.
Yeah.
And now you have to go to the next tutorial, which we'll do the next time.
Okay.
Yes, if you click on next. Yes. This time we are going to upload these logs. This is a part of the data pipeline because they also want us to work with unstructured data. And logs are unstructured data. So this is how you upload a log from one place to the other. This is first is make directory. So we are going to make a directory on the Hadoop file system, and the next command is to copy from local.
Okay. So shall I copy this?
Yes, you copy this. Do you want to do it today, everything?
You wish if you want me to connect some other time,
It's up
so
to
I
you.
can do.
If you're not, if you're getting like, if it's getting too tricky or too, but I think you are picking it up. So let's try to complete as much as we can.
No problem. So we can connect in some other time. So in the meantime, I'll review
Yes,
all these
because
things.
I think you can do a lot of stuff on your own, and whenever you are stuck, we'll do it together.
Yeah.
So let's do an hour on Monday or Tuesday, whenever you are free, from like 8 to 9 or 9 to 10, whenever, whichever time.
Oh, evenings.
Yes. Are you
Okay. Yeah. Sure.
Okay.
Yeah.
Okay, then I'm going to see you.
Okay, I'll put a message or some email to you so that we can fix the time.
Yes. Nehal is going to help us synchronize the time.
Right. Thank you for your time. So really
You're
enjoyed
welcome.
learning the new thing, and of course I asking. Sorry if I
Oh, it's
asked
okay.
any
You
stupid.
can read
If I
you can
asked any
read
stupid question.
you can read these tutorials line by line slowly to understand the
Okay.
whole story.
Okay.
Because
Yeah.
we did a lot of stuff. We did like 4 or 5 pages. You can read it
Yeah.
line by line what we actually did.
Okay. So I think somehow I missed during introduction. So you're Shivagan, right?
Yes, I'm Shivka.
Okay. Sorry to ask you.
Oh, it's
So
okay.
yeah. Okay. Thank you, Shivagan.
You're welcome. I'm going to
Yeah, I try
share.
to email or text you so that we can whenever you are free. So we'll connect. If somebody is joining at that time also, that's good.
Yeah, Nehal and Pavas are generally taking this course and they
Mhm.
helped me to take this.
Oh, great. Okay. Yeah. Yeah. Thank you, Shivagan.
Okay, bye bye.